Welcome to the 100 Doors Coding Challenge in Python. The idea with this challenge is you have 100 doors in a row and you're going to make passes along all of those doors and you're going to change their state. So if they are open, you're going to close them, and if they're closed, you're going to open them. And the question to investigate is, after 100 passes, which doors are going to remain open? Let's make a start. The first thing we need to do is we need to think about a way to represent our doors. And the way I'm going to do this is I'm going to use Boolean variables. Now, Boolean variables are a data type which can either be true or false. And we're going to have false represent a closed door and true represent an open door. So I'm going to make a list of these. So we're going to have false, and I'm going to have 101 of them. Now the reason for this is because Python lists start at the 0th index. I actually want to ignore that 0th index. So I've got a direct mapping between the door number and the position in the array. Okay, so let's print this and see what we got. So I save and hit F5 to run on Windows. And you can see here we have this list containing 100 false, so that means 100 closed doors. Now let's just do one pass along the doors and think about how we're going to do that in code. We're going to use a for loop, and I'm going to use I as my counter variable. You can use X or anything you like. So for I in range, and it's going to be from 1 to 101. So it starts at 1, stops at 100. This is the way these arguments work for the range function. You always need to go one further than the actual last number that you want to use. Okay, so we're going to do doors I. So this means for the ith door. So it's going to start off with I being 0, and then it's going to be I equals 1, I equals 2, all the way up to I equals 100. So this particular door that we're at currently, we're going to change its value. Now there's different ways of doing it. We could use like if else, but it's quite nice to use not, because with Boolean logic, not false is true and not true is false. So that's quite an easy and tidy way of doing it. So now, if I print my doors and save and run, you can see they're all true. So I've done one pass and the state of all the doors has been changed from false to true, or from closed to open. Now another construct you're going to need to complete this task is what we call nested for loops. And before we apply those to the actual task, I'm going to show you them in isolation so you can see how they work. So let's have for x in range, and let's just do 1 to 6 here, which will actually be 1 to 5. Gets confusing, but you'll get used to it eventually. And then inside that block we have another for loop. So for y in range 1, 4, which really means from 1 to 3. And then inside that nested construct, we're going to have print, and then we're going to have x and the value of x, and we're going to have y and the value of y. Okay, so let's save and run. Actually, before I hit run, have a think about what you think the output might be for this. You may wish to pause the video while you do this. Okay, so the output is we have x is 1 and y is 1, and then x is 1 and y is 2, and then x is 1 and y is 3. So that is the inner loop giving us our y value. So while x is 1, we get 3 values for y, and then once we've finished all of those y values, we go back and we increment the x, and then we go through the y values again. So let's see how this aligns with the code. So x starts at 1, and while x is 1, we have all these values going from 1 to 3, even though it says 4. And then x increments to 2, and then we have all these values from 1 to 3, and so on until we get x is 5 and y is 3. Now, this nested for loop is the key to solving the 100 doors problem. So make sure you understand what's going on here. If you need to take some time and do some experimenting, write a few more examples of your own to really get it, then I encourage you to do that before we move on. However, there's one more thing that you are going to need, and that is the third argument to the range function. Let me show you how this works. For I in range, and let's have, so we're going to start at 1, And then we're going to stop at 10, which means we have to put 11 there, which you will get used to eventually. But then there's a third argument we can have, and that tells us the step. So now when we print I, if I add my colon, have a think what's going to happen. Now I'm going to run it. Okay, so this is the output we're interested in down here. So we get 1, 3, 5, 7, 9. Okay, so we get odd numbers. Why is that? Well, it's because we started at 1, and then we're going to go all the way to 10, but we're going to go in increments of 2. So the next number after 1 is going to be 3. And then we stop at 9 because we're not going as far as 11, because, as we have said before, that's always one higher than the value that it stops at. And now we're going to go for the actual solution. But I really hope at this point that you've had a really good go to try and solve this problem on your own. And it doesn't matter whether or not you've actually correctly solved it. It's the getting stuck in, getting your hands dirty, writing some actual code, making some mistakes, reasoning about those mistakes. That's how you actually develop your programming skills. So don't just wait for the solution to be given to you. Okay, let's go for I in range. And we're going to go from 1 to 100. And then our inner for loop. And I've used different variables here. In the example for the nested, we used x and y, but I'm going back to I and j, which are quite common names for counter variables. So this is in range. And this is the clever bit, okay? So you may not have spotted this yourself, but what we're actually going to do is we're going to use the outer variable counter, that's the I value, as the first step. Because on the first pass, you want to check the first door, etc. But on the second pass, you want to start at the second door, and on the third pass, you want to start at the third door. So that I value is where we start. And then we're going to go to the end of the row. But then again, the really clever bit here is we're going to use the outer counter variable, the I, again, to specify the step. Okay, so on the first pass, you want to go to every single door, so your step is 1. But on the second pass, you want to go to every second door, so your step is 2. And very conveniently, the I value at this stage is 2, etc. for every pass that we do. Now, it might take a bit of thinking about to understand why, but it's actually the inner loop where the flipping happens. Okay, so we've got the outer loop is telling us which pass number we're on, but then the inner loop is doing that particular pass. So it's doors J that gets flipped. So now the state should be how we want it to be to solve the problem. So let's print doors and see what we have. Okay, so we've got false, true, false, false, true, false. Now this is quite hard to actually make sense of, so I'm going to print it in a different way. I'm going to do for I in range 1 to 101. So this is for every door. Then if doors, so if this particular door is true. Now technically you could leave out is true, because if doors I means if doors I is true, but I like to make it explicit. And notice I'm not using equals here, I'm using is, because it's Boolean. So if this one is true, then only then I print the value. And I'm going to use this end equals comma space. This is just a nice way of using the print function to format our output. So now when I save and run, okay, so here we get the doors which are open at the end of 100 passes. Now some of you might recognize these numbers as being the square numbers from mathematics, which I think is a very interesting fact. And those of you that are really into maths might want to think about why this might be the case. But that is by no means obligatory. And if you've got this far and you've understood what we've done, then well done. And I hope you've enjoyed this challenge.